Hey guys, I wanted to talk to you today about a fun little problem I found in a GRE review guide. And so, for those of you who think you'll never have to answer questions like this again, if you go to grad school, you're going to have to take the GRE. And here's a problem that deals with a lot of the probability concepts that we've been talking about. So, I wanted you guys to think about it a little bit. So, the problem says, a game is played by randomly selecting a box, and then from that box, you draw out two chips without replacing. So you draw the first chip, and then you put it to the side, and then you draw the second chip. Now, the two boxes are box A, which has 4 blue chips, and box B, which has 2 blue chips and 2 red chips. Now, the boxes aren't labeled, so you've got a 50% chance of picking each box, and you're then going to reach blindly in and pick one chip, and then pick another chip. So, what you might want to do is actually pause the video at this point and think about, okay, what are the odds that I'm going to pick 2 blue chips in this game? What are the odds that we'll say a win is pick 2 blue chips? What are the odds for that? So feel free to pause the video and think about that, and then come back whenever you want. Okay, so now that we've thought about it a little bit, we realize that easy questions are, what are the odds that I'm going to pick box A or box B? Well, it's 50-50, the boxes aren't labeled, so the odds are totally even. It's a 50% chance I pick box A, and once I've picked box A, I know for sure I'm going to win because there's nothing but blue chips in that box. So the easy question is, given that you've picked box A, what are the odds that you're going to win? The odds that I'm going to win then are 100%, 1. The probability is 1. If I pick box A, I can't help but win this game. So this means that which box you pick is certainly not independent of whether you're going to win or not. Remember, it's independent if they don't affect the probabilities at all. So if you know which box you picked, someone says before you draw the chips, oh, you picked box A, you said, well, I'm not even going to bother drawing chips, I know I've won. So now the question is, well, what if you pick box B? What are the odds of winning if you pick box B? So I'm going to ask, what is the probability of a win given that I've picked box B? So now I need to draw the tree for box B, and I need to figure out, I only win if I pick 2 blue chips in a row. So I'm sitting here with box B, and one thing that can happen first is I pick a blue chip. The other thing that can happen is I pick a red chip. So blue chip, for my first draw, there are 2 blue chips and 2 red chips. That means the probability is 1/2 that I'm going to pick blue, so 1/2 on this little tree branch, and then the probability that I'm going to pick red is 1/2. And now if I pick red, I don't have to keep going. I only win if I pick 2 blue chips, so if I pick 1 red, game over. I don't even have to continue this tree. So what we see already is that if we pick box B, the probability of losing is at least 1/2, and now we got to continue on our blue path and say, okay, if I was lucky enough to pick that first blue chip, what are the odds that I'm going to pick a second one? Well, now remember, it's without replacement, so the blue chip I picked is gone, it's over on the side, and now I started with 2 blues, 2 reds. I only have 1 blue and 2 reds, so I only have 1/3 of a chance of picking another blue. So now, going from here, picking another blue is 1/3, and then picking a red at this juncture is whatever's left over, that's 2/3. So the odds that I'm going to start with box B and then win is 1/2 times 1/3, because with these tree diagrams you multiply the path along. So there's only one way to win this game, and you're only going to do it 1/6 of the time. There's 2 ways to lose the game. You start with a red, and that happens 1/2 the time. Or you start with a blue and then get a red, and that happens 1/2 times 2/3 of the time, so that happens 1/3 of the time. So the probability that given box B that you're going to win is equal to 1/6. And remember that the probability of winning given box A is 1. So which box you get and whether you're going to win or not are definitely not independent. So now let's build the whole tree. What's the whole tree for the game? Well, so before we can start with what we're going to pick, we have to start with which box we're going to pick before we can talk about the chips. So from the very start, one of 2 things can happen. Either I pick box A, and that happens a half the time, or I pick box B, and that happens a half the time. And now if I pick box A, I have definitely won, so that's a win right there. So there's a winning leaf, regardless of what happens with the chips. Now if I picked box B, that's a half the time, we know that I can win, and that's going to happen a sixth of the time, or I can lose, and that's going to happen the rest of the time. That's going to happen 5/6 of the time after I picked box B. So now to figure out what are the total winnings we multiply to get to the winnings. Well, there's obviously one of the wins is just a half here, because I just pick box A and you won already. Now the win with box B, half the time you pick box B, and then a sixth of the time you win out of that. So that win happens 1/2 times 1/6 of the time. And that's actually 1/12. So the total probability of winning this game overall, the probability of a win, is equal to the half the time you pick box A plus the 12th of the time you pick box B and win, so that's 7/12. But remember, the probability that you win given box A is equal to 1, because that always happens, and the probability that you win given box B is equal to 1/6. Once you know you've got box B, you're going to have a tough time winning this game. Overall, if you don't know anything about the boxes, you're going to win more than half the time. So I encourage you, when you read about things like dependent, independent, joint probabilities, this kind of thing, think about this simple tree, think about this simple game, because there's actually a lot there. One last thing is another concept we hear is the idea of mutually exclusive. So two things are mutually exclusive if they never happen together. So in this case, the mutually exclusive event is, what's the probability that you're going to lose given that you've picked box A? So in general, the probability you're going to lose is the leftover, it's 5/12. But if I know I've picked box A, I can't possibly lose. That means the event picking box A and losing, those two events are mutually exclusive because they never happen together. So anyway, I hope this has cleared things up. Feel free to think about this game. Please feel free to email me about this game and about this question, because I think it's a nice, simple one, and a lot of different things are happening. And I will talk to you next week. See you then. Bye.